Morning, students. So as we have started with the measures of dispersion, in that we have discussed about the methods of measuring the dispersion. So we have discussed the 5 methods, that is range, quartile deviation, mean deviation, standard deviation and Lorentz curve. But the first 3 methods, they are omitted from our syllabus. So we will be discussing standard deviation and Lorentz curve. So firstly, what is standard deviation? Standard deviation is the square root of the arithmetic mean of the squares of all deviations. And deviations, they are taken from the arithmetic means of the items. So this formula, it would be more clear when you use it. We have 3 methods of calculating the standard deviation. It is denoted by this sign, that is sigma. 3 methods are direct method, shortcut method and step deviation method. So firstly, we will be discussing about the direct method. Formula for direct method is under root of sigma x square divided by n. So how we have to use this formula? Suppose we are given this data in which serial number and x, that is marks of the students, are given. So total number of students are 10 and their marks are given. So we are using the first method, that is direct method. Firstly, we will find out the mean of this method. How to calculate mean? Sum of deviations divided by number of observations. So sum of deviations, sum of observations means when we sum it up, it comes out to 110. When we divide it by number of observation, that is 10, it comes out to 11. So mean is 11 over here. So the next step is we will be taking deviations from mean. That means we will do x minus of mean. We will subtract each value from the mean. 12 minus 11 is 1. Then 8 minus 11 minus 3. 17 minus 11 6. Over here we will not be ignoring sign. We have to use the sign as well. In case it is negative, you have to write negative. Clear? So when we sum it up, it comes out to sigma of x, which is equal to 0. After that, the next step is we have to square it up. Square of this x is equal to square of 1, it's 9, 1 minus 3 is 9, 6, 36, 2, 4. Likewise, we have got the sum, square root of the numbers. Then we have to find the total of its, that is sigma x square, which is equal to 244. That is the sum of these numbers. Clear? Then we will use our formula. Standard deviation is equal to under root of sigma x square divided by n. Take care, we have to use the value of sigma x square, this one, not the square of this. Clear? So 244 divided by 10, we have to find the under root of 24.4. It comes out to 4.94. Clear? Then from this standard deviation, we can find out the coefficient. Coefficient of standard deviation is equal to standard deviation divided by mean. So we have already calculated standard deviation. We have the value of mean as well. Substituting the values, we will get the coefficient is equal to 4.94 divided by 11, which is equal to 0.45. So this is a value of coefficient of standard deviation. This is in case of direct method. After this, we will be using the shortcut method. The second method, shortcut method. What is there in the shortcut method? Serial numbers are given. Again, we are given the marks. So in order to make it easy, we will be using a shortcut method. How can we make it easy? We will assume any value. You can take up any value as assumed. Over here, I have assumed 20. So next step is we will be subtracting each value, each marks from the assumed value. It's 8 minus 20, 10 minus 20, 12 minus 20. So similarly, again we will not be ignoring signs. So we got these values. When we square it up, we will get 144, 100, 64, 36, these values. Clear? So sum of these values and these values. Method. The formula to calculate standard deviation for shortcut method is under root of sigma dx square divided by n. Dx means deviation from x or the marks minus sigma dx over n whole square. So dx square means we will be taking this value 420 divided by total number is n minus it's minus of 30 divided by again n, that is 10. So we will cut this 0 by 0. We will get 42 minus 3 minus 3, then that means it's 3 square. So 42 plus minus 9 we will get as 33, and under root of 33 is 5.74. So this comes out to the value of the standard deviation in case of shortcut method. We have discussed two methods till now. The third method is step deviation method. How to calculate mean in case of step deviation method is, again we are given the serial number and the income of the people is given. So firstly what we have done is, as we have done in the shortcut method, we have assumed any value and we have find the difference between the assumed value from the monthly income, that is dx is equal to, this we have taken as x, dx is equal to x minus a, where a is the assumed value. Clear? So it's assumed is 1000. So 500 minus 1000, it's minus 500. 700 minus 1000, it's minus 300. Over here 0, then 500, 300. Clear? So over here sigma of dx, it comes out to 0. Clear? Then we have to find d dash x. D dash x means when we divide it by the common difference. Over here we can say it's 500, then 700, it's 200. So we are not having constant difference, we have taken the common difference as 100. So common difference is equal to 100. When we divide these values by the common difference, we will get the values as minus 5, minus 3, 0, 5 and 3. Clear? So squaring it up, we will get 25, 9, 25, 9. So sigma of d dash x square. D dash x square means we have divided by the difference by the common difference. Clear? That is 68. So using the formula, standard deviation is equal to under root of sigma dx dash square divided by n minus sigma dx dash divided by n square multiplied by c. So over here take care while you are substituting the values. Dx over here dx dash, that means we will be taking this value 68 divided by n is 5 minus d dash x. D dash x is 0. So 0 by 5 square multiplied by c is 100. So when we calculate this, it comes out to under root of 13.6 multiplied by 100. So we will get the value of standard deviation as 368.78. So we have discussed all the three methods today. Using these methods, you will calculate the standard deviation of the assignments which will be given to you. Thank you.